I'm going to go over authentication with Auth2 and OpenID Connect. So this lecture is more specific about using MIT Kerberos to log people into your app. So a lot of people had applications that use that mechanism, that wanted to use that mechanism, and this will kind of help you use that. Okay. All right. So first we need a couple of motivation points to start off. So we want to have users use our application, okay? And users are complicated. They are lazy. They don't want to create a new account just for our application. They would have to create a new password and all these things, and they're lazy. They don't want to do that. And the other thing is we don't want to create our own system for security. To say we don't want to store passwords in plain text because that's insecure. People could steal it easily and cause havoc. And also we want users to trust our application. So that's the goal that we want. And how do we get that? The solution is to use Auth 2.0 and OpenID Connect. So what are these things? So these are just things that are copied and pasted from the official websites. Auth 2.0 is the industry standard protocol for authorization. And OpenID Connect is a simple identity layer on top of Auth 2 protocol. So basically here, Auth 2.0 is just the authorization mechanism, and OpenID Connect is the verification mechanism. And when you add the two, you get authentication, which is logging users into your application. So I actually went online and looked up the meaning of the word anti, and it actually doesn't mean anything, but somehow they put it in the middle. But anyway, so what I want to emphasize with these two things is that they are protocols. They are not framework, they are not application, they are not algorithm, they are just protocols. So they are a set of rules that the internet community agreed upon and sort of enforces applications to use whenever they want to use these protocols. So for example, when Facebook says we are using Auth 2, it just means that they're obeying the same principle that the internet community agreed to obey. And same for Google, same for MIT OpenID. And the cool thing is that since everyone obeys the same principle, it's very secure. That's one of the things. And it's easy to implement when you understand what is going on. So before we get into how it works, we have to go through a couple of definitions. So in transaction using these protocols is basically whenever you are logging in and having to go to the Google this application wants to use the Google stuff, get your user ID, etc., etc. And the user is the person who is using your application. So that's like when you're gonna get MIT student to use your app. The user is an MIT student. The client is your application. This client involves the web page that you create with your server. It involves your server also, and your client will need a client ID and a client secret, which it gets from the authorization server. So what is the authorization server? The authorization server is, in this case, it would be, for example, the Facebook server or the Google server or the MIT server. That server is, the main goal of it is to authorize people to use the application. And then we also have the resource server, which is the guy who is kind of the bridge between getting the data that you want from your user and the user, the client actually. So I kind of have a visual representation of that, and this is kind of what happens. You have multiple interactions. I wrote transaction, but I meant interaction between all these components, and the user never directly communicates to the resource server. And the time it communicates with the authorization server is when the user is saying, I authorize this app to get my stuff from Facebook. Usually they might ask for your profile name, or they might ask for your birthday. Some people might ask for your friends list and things like that. So a couple more definitions. We have scopes. What are scopes? Scopes are the set of data that you want to get from the resource server. So, for example, when you're creating your Facebook client, if you remember when Aaron gave his lecture about the client authentication, at some point, I don't know if you remember, but you had to choose what things you're looking for from the user. For example, say you wanted to get the profile. Usually the profile means that you want to get the name, family name, and the basic information about the person. And there is always the ID, which is like this ID represents your ID within Facebook. You could also have friends, like get the friends list, and there's multiple things. It really depends on what platform you're using. Like a bank account could have a scope as like your transaction history. That could be one of the scopes from a bank resource. So, and finally we have grant types. Actually, I just want to go back to the scope. The cool thing about scopes is when in the past you used to give the client, that is your application. In the past, you used to give the client your username and password, and then the client had access to everything. But now this time you know that your client doesn't have access to everything. Your client only get access to what you ask for from the resource, from Facebook, from Google, or MIT. So that's the thing that this scope solves, which is a really good property. And then, so we have grant types. So grant types are just the type of access that you get from the authorization server. So even though we used to give your username and password, the Auth2 and OpenID Connect protocols also include different grant types. Like the implicit grants, actually no, the resource owner credential grant type is when you actually give the client your username and password. So they still allow these things, but the thing is, whenever you're creating your client through the resource, you always have to choose what grant type you're giving to your application. And here we're only going to focus on authorization code and refresh token, which are like the most widely used. Usually when you log in, when they say log in with Google, log in with Facebook, that is usually what we use. The other types are more for when you're developing your app, and it serves different purposes. If you want to read about that, there's multiple links online. And so what is the authorization code grant types? This authorization code grant types allows your client to get a specific subset of data among the entire user's data. Remember with the scopes, it allows you to get just a specific from the resource server's database. And how does it get this? In some ways, you're going to get an access token, which is it's kind of like a key, and that key is a very special key that expires. It expires after a specific amount of time, which you actually set. You could say, I want it to expire after 1 hour or 1 month or 1 year, but it always expires. And that key also, that's the one that gives you access to the subset of data. Where that key gets generated when the person authorizes the app, And that key is very special because it doesn't give you access to everything. It only gives you access to a specific subset. And the refresh token is this other key that almost always never expires. Sometimes it expires, but almost always never expires. And the refresh token allows you to get a new access token, if that makes sense. Sometimes, for some other reason, you might want to be able to get a new key so you can keep having access to that data. Okay? Is anybody lost, or does this all make sense? Sort of. Okay, we'll have more. So I meant to skip this, but we're just gonna go over it then. So anyway, so we're back to our visual representation. Here we're going to show what the transaction looks like. So if you remember in Aaron's lecture, he showed that you had passports, Facebook on this side, and then you had your server. And it was kind of like passport taking you to Facebook, and then Facebook taking you back to your server. But that was like a two-way thing, but there's actually more that happens. So here we go. So first, the user sends to your client he says, oh, I want to log in. And this will be like login with Facebook. What does your client do? Your client sends you back to your user, and it redirects you to the authorization code. That is when your client sends you to the Facebook page to log in. And then what happens? You get the Facebook page from Facebook, and Facebook just returns that page. And then usually, if you're not logged in, you would have to log in. But if you're already logged in, it will make that authorization page saying, this application wants to get you some of your credentials, and do you authorize this application to get it? And that's where you say yes or no. Usually, people say yes. And when you say yes, you authorize the app. You send back another transaction to the authorization server telling them, I authorize this app. And what does the authorization server do? The authorization server returns the access token, which is specific to the client and specific to the user. And that access token gets sent back to the user. And now the user is going to send that access token to the client. And now that we have this key, we have access to the data. So the client is going to go to the resource server and say, yo, I have the key, give me the data. And the resource server is going to check the key and be like, oh yeah, this works. So it's going to give you the data, send it to the client. And at this point, that's when your client actually logs you in. You're in a state of being logged in, and it will log you in and then redirect you back to whatever was needed, like a home page or something. So, this is not actually what happens. It's slightly a little bit more complicated than this, but it's not as bad. So I'm going to show you actually what happens. And so here again, the user says, log me in. Okay? Then the client is like, it redirects you to the authorization server, but at this time it redirects with the state and a client ID. The client ID is just a way for the authorization server to identify what application is asking for authorization. And the state is just a random string. And usually this string, for security measure, this string gets generated every time these things happen. And then you get the authorization server, you get the authorization page, and you authorize the application. That's the user doing that. And then when you authorize the application, the authorization server returns the same state that you initially sent and an authorization code. It doesn't return the access token yet. This authorization code is also specific to both the client and both the user. So now that we have the authorization code and the state, we return both of these things back. For here, ideally the state hasn't changed. The state is the same. This state over here is the same state as here. But why do we get this state variable? It's just a random string, right? This state is some ways of security measure. So sometimes you could have a hacker come in somewhere in between any of these steps and mess with the transaction. When that happens, something, I don't know how it works exactly, but something will trigger the states to change. So when your client gets back this authorization code and the state, it will check if this state is this state the same as the state that I sent. If the state is different, the client will say something wrong happened. I'm going to stop the transaction right here and say there was an error. That's why we get the state. It's just for security. So then at this point we don't need the state kind of disappears. Then the client will send the authorization code. And remember, you get a client ID and a secret when you're creating your client. The client will send the authorization code, send the client ID, and send the client server, the client secret. So at this point, it's kind of redundant again. Why do wasn't this client ID the same as we sent earlier? And on step 6, actually step 5, that was the same ID that we sent earlier. So this is another security measure to check that is this code coming from the actual client that I gave authorization to? And does this client have the secret? That's like the password. And that's why they say it's a secret, because you're not supposed to let anybody know of your secret. Usually your ID is kind of public. People can identify that. But the secret is very specific. You don't want people to identify your secret. So it will check if all these things are matching. When it checks that, it returns the access token. So here's now we have the key. And this key is specific to our user. Now that we have the key, we could get the user data anytime, as long as the key doesn't expire. We send the key to the resource server and say, we want data that is specific to this user. And the resource server checks and agrees and sends the user information. Finally, there's this endpoint auth resource callback, which you will see in the code, which basically logs you in and sends you to the home page again. So this is roughly what happens. And whenever, say, Facebook or Google or anyone else wants to say, my resource is using OAuth2 or OpenID, there is some other organization that is actually going to check if, do you abide by all these principles? If yes, then we're going to allow you to actually say that we use it. So that's how like this whole check happens. And this is a very secure measure. And the good thing is that now your user doesn't need to have to create a new credential just for your website. They could log in with your other things. So how does this change when we're doing this with Facebook? Because over here we have this, right? So when we're doing it with Facebook, the only two things that change are these two endpoints. Instead of saying auth resource, it says auth Facebook and auth Facebook callback. And these are just kind of like, they're like variables. They don't really mean anything, but this is for us to know that this is actually using Facebook or this is actually using something else. And what if it's MIT? You could name it OIDC, which stands for OpenID Connect. So what about the refresh token part? So remember when we got our access token over here, we're actually going to when you add the refresh token implementation, it is actually going to return both the access token and the refresh token. And once you have the refresh token, this interaction, so whenever your user goes into your website and logs in, this is going to be happening multiple times. And your server, at some point, your server is going to send the access token, and the resource server will say, yo, this doesn't work, that access token is wrong. And your server will recognize that, oh, it's probably because my access token already expired. So what it's going to do is, it's going to do some other interaction here, not with the alternative code because that already expires. is going to send the refresh token to the authorization server, and the authorization server is going to return a new access token and a new refresh token. And that just happens over and over and over and over until the user revokes the access. So the user is able to say, I don't want this application to use my stuff anymore. I'm going to revoke it. That's what happened. So yeah, that was just like the high level of what happens. So this, here we have a skeleton code. You could look at it whenever you want. It just kind of, it's a guide that shows you how to do this in code. And I'm actually going to demo what this would look like. And anyway, so. Are you guys able to see this? So this is, oh, good. So this is our, remember when we made our Catboy application? In our navigation bar, we had, we check if the user is logged in, if the user is logged in, we do something if the user is logged in. And if it's not logged in, we tell them you have to log in if you click on this link. That's what this is doing. And over there, I just changed the text to say, if you're logged in, the page is going to say something. Now you're logged in, and with MIT OpenID, and your name is this. So. So I'm just gonna I'm first going to show you what this looks like, and then we can walk through the code. npm start. If I go on localhost 3000, this is what it looks like. It says that I'm not logged in, and over here I can click on login. It will take me to the MIT page, and I can add my username and put my password. And when I click login, now it says that I'm logged in with MIT OpenID, and my name is Robert M. Cleven. So that's what it looks like right now. If you click on this GitHub page, see GitHub, it takes you to like a guide on how to do this. And there's two guides. You could either copy and paste this, the code that generates this page, and modify it to fit your application. Or you could look at the guide that shows you how to integrate that thing into your application. It's a little bit more, there's a little bit more stuff you have to do because it's kind of like trying to put stuff in your application. But it just does the same thing. And there's kind of a lot of steps that you have to go through. So, yeah. Does anybody have a question? go 614.io MIT OpenID. And so I'm just gonna walk through the code. Okay. So in our page, in our navigation bar, if you're logged in, the navigation bar will look like this. It will say log out, and if you're not logged in, it would say log in. It would look like this. It would look like this, log in right here. And that's what this code is doing. That's just, you've seen it before. That's what it does in the navigation bar. And for the page, this is just basically saying you're not logged in or you're logged in. Actually, we didn't go through this page because I think I already authorized the app, but this is what would happen. Like over here, it says this thing will give you access to your login identity, basic profile information, email address, and offline access. The offline access is the refresh token part where you can refresh anytime the server needed to. And so then, in your database, you just have to have your MongoDB URL. And there's a file called OpenID credential, which has a section with clients and a section with auth. You don't need to worry about the auth section. It doesn't really mean anything. And in the client, you just have to add your ID and your secret, which you get from creating your credential in this website. There's a guide that takes you through that as well. And after that, in your app.js, you have to, there's a folder called passport.js, which we'll get into, which is the next thing. You have to import that file, and you have this, you have to use sessions. Just kind of have to copy and paste this line. I didn't really explain what it does exactly. And once you have it, once you have that, you have these two endpoints, which, if you remember in the diagram, those right here. This is where you say log me in. When you log in, it's going to do this, and when you say the callback, which is this guy, this is what happens when you take the callback route, if that makes sense. And then the complicated thing in this code is the passports file, passport.js. So with Facebook, it was a little bit more simple because we didn't have to worry about all these other things. But with MIT OpenID, you actually have to do a little bit of an extra step to get the user's information. And so everything looks the same to Facebook up to a certain point. I'll just walk you through it. So passport, we always import passport. And we have this thing called OAuth2 strategy. Yeah. And there's another thing that we added, which is request, that we didn't have with Facebook. Request allows you to make API requests inside of your server. And then we have our user model. And this is, if you remember the file OpenID credential, this is actually loading that file right here. Once we load the file, we need to create the passport parameters. In the parameter, we have the authorization URL, which is just the MIT URL right here, and then you say /authorize. And token URL is the same thing, but at the end you do /token. And the main things are your client ID, which you have to add here, and your client secret, which are taken from that credential file that we added earlier. If you remember, client ID, and that's what we have here, client ID and client secret. And then the callback URL is just the host plus that callback that we had earlier, this callback right here. And what is the host? The host is just the page. The host is like the page page for your server, like the host for your server. Like in this case, if you're running it locally on your computer, it would be localhost. But you may, we're gonna get into the deployment lectures soon after this. If your app was deployed on some online website, your host will be different, but your callback URL will be different. And then there's this line where we say passport use. So passport allows us to do like this part of the mechanism all the way to where we get the access token. At Facebook, the Facebook authentication allows us to do everything up to like right here, where we log the user in. But with this thing that we're doing, OAuth2 strategy, we don't get to do this part. We have to do this part ourselves, and that's. And then that's what the stuff inside of this code block does. Then here we have the request that we added earlier. In the request, the first parameter should be the URL where you're making your request. And the second parameter is like the callback. So to get the URL, I added this method here which says build user info request parameters. And this just returns this. I didn't want to put it here because it will be confusing, but basically it creates an object that has the URL and it has headers. In the header you have this thing called says authorization. The first thing is bearer plus access token. The access token, that's where you put the access token to say, that's like right here where you put the access token in your request. And then once you have the parameters, you run inside of this function. If you didn't have an error, then you find or create the user. But if you did have an error, you will say that you call this method that says done, which is a passport method that tells your, it has two parameters. The first parameter is an error object, and the second one is the user. If you have an error, it will ignore the user. That's why we only put the error object inside. So it says we're done, and we had an error, and that's what we put here. An error occurred while making the access request. And to find the user, it's this method here, which is Mongo database, where we say user find one. We find it by the user's information.sub. SUB is, I don't know what it stands for, but that's like, for Facebook, it will be your Facebook ID. SUB is like your MIT ID. So you find the user by the MIT ID. If you find the user, you're done, and you just return the user right here. If you